So I'll, despite my earlier session, I'll try to go as quick enough through this so we can have the chance for questions if we want to. Prior to this, I was with the hat on for the co-leading the MDC group. Today, I'm tooting a little bit more my own horn. My name is Karl Rabe, and I'm the founder of a small startup called WoodenDataCenter. And to the surprise of a lot of people in the expo hall, I'm relatively serious about that. Brandon is still up there because he was holding a similar presentation he covered for me last year at the Edge Computing. That's why I think it's just fair to give him credit towards this. So what's the issue, or what happened? So luckily to the keynote, thankfully to the keynote, it was, the ball was shifted to scope 3. So we all heard and read and think about our energy and our energy efficiency problem, but especially the hyperscalers who already are energy companies and have renewable energy in their portfolio, the problem is scope 3. And for Meta, it is per 2020, they have a 99% percentage in the scope 3 of all of their emissions. So when I realized that, I thought, okay, I can't just run my data center on wind energy. I need to address that. And luckily, there is some option. Here's another industry example showcasing that. We talked a lot about the first, or the initial issue with mining and resources that we need in the data center industry and other industries. And even them have a lot of work to mitigate those scope 3 emissions. So my background in the data center industry was in trying to use renewable energy to create a sustainable product and to compete with the Nordics within Germany, which I successfully failed upon in the sense that we were not able to crack the German energy system, but we had a lot of very interesting insights, pioneered heat reuse somewhat on a different scale than other people here in the room in Germany, but eventually came to a point where the data center in the middle just looked clunky, not really optimized for OCP, and so we started building it for our own use, starting building a wooden data center, which was inspired by a Swedish fellow you probably heard, who's called Lars Sjödin of Eco Data Centers. Scope, this is still in there because usually in Germany I have to talk about the measurements of that. We heard a lot about it, so I'm skipping it. The part of low carbon materials is just, a small part of trying to get as close as possible to net zero. And in that aspect, I looked at a lot of things and I tried a lot of things to get down there. Integrated energy, I believe, is the biggest chance for data centers to be part of the industry without fearing repercussions using so much energy, but with the backup generators and the batteries being put to use, stabilizing the grid and supplying heat towards use cases, that is really important. Circular hardware, reuse, recycle, repurpose, we heard that. That is important to get down in cost and better in sustainability. Low carbon materials, we jump into right away. And overall, you have to check not only for your total life cycle of ownership in terms of cost, but also in terms of CO2, and the life cycle assessment is an important part of that. So why is my company called WoodenDataCenter instead of Concrete Steel Data Center? And that's the relatively easy why. So there is a material existing that is drastically lower, but supports, repairability and engineering properties to build out housing infrastructure or hosting infrastructure and avoids the two big other competitors, which are drastically a drastic problem not only in the data center industry, but also in all other building industry. So the thing that I'm using or we're working with closely is either CLT and GLT. CLT in that is somewhat special because most questions revolving about why are you using wood and why hasn't this been done before is that CLT is actually rather young material, only 25 years old for the most part. And by cross-laminating or glue laminating different individual natural products together, you get repeatability in the material for all the measurements you can have. This is also something you have in terms of the prior session where we talked about pre-engineering and pre-manufacturing. This material needs an engineering approach to get the repeatability you want. This is CNC machine. This is not a craftsman's approach or a carpenter's approach. You have to use engineering tools to do that. And on the right, if you compare concrete steel sheet metal building in terms of a CLT building, in the right scenario parameters, you actually can be carbon negative. So that's the information is there in the Canadian CLT handbook. If you want a copy of that, I'm happy to send the link out. What to do so that your shiny data center is not burning off or just compliant with a Tier 4 infrastructure. There are some things to consider with CLT, and the biggest issue you have to have it is to keep it dry, because humidity makes wood rot, rotten wood loses its structural integrity. So you need insulation, you need weather protection. A Tier 4 requirement is actually that tight that you have to have still steel as a steel armored plate, but it's drastically reduced compared to other Tier 4 designs. A Tier 3 design in Germany actually can be without a steel armored plate. We have additional coating on the wooden layers inside and outside, so that you increase the fire resistancy of wood. But it's, to my surprise, I didn't have to develop any of this. It's very much known in every industry, in every nation, how to build an F90, F60, or even F240 building in wood. This is an important picture to think about, because the natural question is wood is burning. That's true, a twig is burning, it's flammable, but those big slabs of CLT is actually only charring. And by charring down at a defined rate, it is actually keeping its structural integrity better than steel and concrete. Here's some examples of those things existing in the wildlife. Cross-laminated timber is not only used to build more technical buildings, but also to build skyscrapers traditionally associated with steel use. The pioneers of that is Sweden with research facility, or the mentioned Ecodatas facility in north of Sweden. So some of my own projects that we are working closely on, I've built the first wooden 19-inch rack, and I give a public promise here to come with an open version rack 3 to Prague. The bus bar I have to buy from Amphenol, but other than that, it will be mostly wood. We do support customers also on server optimizations on OCP, and on the bottom left I want to highlight this was a specification we handed in last year in the Future Technology Initiative, which is a wooden construction with a DC busbar system that is superconductive. You can research that and download that specification too. And we have, in the middle, we have a direct connected heat reuse case with a fish farm and an immersed cooling tank. That's also a liquid cooled system that directly has a use in the heat reuse space. And a lot of those designs are updated and even grown in size and professionality. And we are because of the short length of our startup, we actually are now in projects in building fish farming and wooden data centers in parallel. Something I wanted to highlight, although I talk about wood a lot, and that is obviously something that's close to my heart, there's drastically development in reducing the CO2 and carbon. I think we saw a Future Technology Initiative paper on algae or bacteria-grown concrete from Microsoft. That was quite interesting. All the other concrete manufacturers have addressed their Scope 3 problem and ways to go down in that. This is something I'm fairly proud of. This is like our bread and butter design, where we work together with a German modular, wood modular manufacturer, where he's been stepping up in terms of building out this modular data center, which can grow just adding modules in the size, and has a double row 19-inch design with air cooling on top. But this is something we are actively now putting into the market and see a lot of positive feedback. And hopefully I can announce soon the first one project. We also believe that the telco deployments can drastically improve. This is something we showcased together with Submer this year at the MWC, because especially Open RAN has apparently a built-in efficiency problem by using commodity hardware. Mitigating that with a liquid-cooled approach and a Scope 3 optimized approach, it is also possible to take out carbon out of the telco infrastructure. And with that, I'm open to questions and happy to answer them. Okay.
Very short, very short. So it's a wooden structure, okay, with earthquakes, with typhoons, and so on. And the second very small question, if you had to bet $1 million, when would be the first large-scale wooden data center for you? What do you think it will happen? Thanks.
So for me,
realistically, yeah.
Realistically, so since this is out there and is verified, I believe this is happening within the next 9 months for me to build such a project. The other question is, since the cross-laminating and wood actually has damping probabilities, so in a lot of cases it is beneficial for earthquakes and hurricanes to have a wooden construction.